Here's page 2. Question number 4. We're given the graph of f, shown right here. We're told there's a vertical tangent line at the point 2, 0. And there are horizontal tangent lines at 1, -1, and 3, 1. And we're asked, on the interval from -2 to 4, so that's the leftmost point on the graph to the rightmost point on the graph, what values of x is f not differentiable? All right, so again, not differentiable means corner, cusp, vertical tangent line, discontinuity. Those are the 4 cases that we discussed in class. Well, we were told there's a vertical tangent line at 2, and we can clearly see a discontinuity at 0. Those are the only issues that the graph has. So our answer is B. Problem number 5, we're asked to find the derivative of this expression right here. I'm not sure if this is ready to be derived yet. The 1/2 x to the 4/5 is fine, but then we see that we have x to the 5th in the denominator. And we don't really want to use the quotient rule. We can. We don't have to here, especially if we just change it to 3x to the -5th power. Now we can do a nice power rule. 1/2 is a coefficient. It stays. 4/5 is the exponent. It becomes part of the coefficient. Keep our variable. We need to subtract 1 from the exponent. 4/5 minus 1 is 4/5 minus 5/5, which is -1/5. Then we have minus 3. 3 is a coefficient. It stays. -5 will become part of the coefficient. X to the -6. Now this is a correct derivative right here. But as I've mentioned a couple times in class, that doesn't mean it will be one of the 4 answers that we see here. We may have to do some work, because certainly we see lots of fractions and we don't have a lot of fractions up here. So we're going to have to start combining stuff. So if we look at the first one, we see we have 1 times 4 over 2 times 5. And then we have x to the -1/5. We can make it a positive exponent by moving this term down into the denominator. We then have -3 times -5, so that's +15. And then x to the -6 is x to the +6. Otherwise. So, looking at our answer choices, we need a 15 over 6. I'm sorry, a 15 over x to the 6th. So B and C are out. And then we need x to the 1/5 in the denominator. This has it. This does not. Our answer is A. Number 6, f is differentiable function. Okay, so the derivative exists for all values of x. And we're told f of 3 is 8 and f prime of 3 is 5. Which of the following statements could be false? All right. The first one says the limit as x approaches 3 of the function is equal to 8. Well, we're told the function is differentiable. That means that the function is also continuous. If the function is continuous, then that means the limit as x approaches 3 of the function must equal the function's value at 3. Since f of 3 is 8, that means the limit as x approaches 3 of the function is 8. That's okay. That's true. B, we talked about in the last class of our notes. This is the alternate form of the derivative. F of x minus f of 3 over x minus 3. If we write that with the limit as x approaches 3 out front, we are stating that we're looking for the derivative. We're told the derivative at 3 is 5, so it needs to be equal to 5. This is also true. C, we see f of 3 plus h minus 8 over h as h approaches 0. This is our definition of the derivative. That's 100% legitimate. All right, this is f of 3 plus h minus f of 3 all over h as h approaches 0 is equal to 5. This is saying the derivative at x equals 3 is 5, which is what we see right here. This is also true. So by the process of elimination, D must be false. But what does D say? It says the limit as x approaches 3 of the derivative is equal to 5. So wait a minute, f prime of 3 is 5. Don't these two mean the same thing? And they don't. Right? We can have a graph where we're dealing with f prime, and as x approaches 3, the derivative is heading towards 5. Doesn't matter which way we come from. Okay. But that doesn't mean that the value of the function will be 5. Could be down here. Could be up here. Doesn't have to be right there. So it could be false.